Okay, here's the plan. So we're going to go through and review for our test. The test is set for tomorrow. We'll kind of see how the review goes. If we get through everything, we'll test tomorrow. If we need another day, if we don't get through everything, we might get pushed off a day, but I think we'll be okay. We'll just see. We'll see where we land here. So first one, and I'm just going through practice problems. These all look real familiar from the review. They're taken just right from the test, so this is kind of what you're looking at. So we start off with just basic inequality. Solve the inequality. So what's the only thing we have to do to solve this inequality? Divide by -2. And what's important about that? Yes, there we go. Because we divided by a negative, we've got to flip that sign. And so we end up with x is greater than or equal to -6 divided by -2 is +3. So there's our solution. They want us to type in inequality first of all, right? Now make sure you're always reading this part in the blue parentheses that tells you what are they expecting for an answer. So there's our first answer. X is greater than or equal to 3. What do they want next? Interval notation, right? So what I would do though first is graph it. Even though they ask you for the graph, I think that's the third question. Do it on paper. Do it in your notebook. Do it on the paper that you're turning in for notes. So you have a graph to look at before you do interval notation. What would that look like? X is greater than or equal to 3 if I graph that. So at 3 we have what kind of an endpoint? Closed because of the equal sign, right? So we get closed endpoint at 3, and we're shading in which direction? To the right. We want values greater than, so we go to the right. So then what's that look like with interval notation? 3 infinity, right? And what kind of enclosure are we going to have at 3? Bracket, because we've got an equal sign, right? Takes more ink to draw the equal sign, more ink to fill in the endpoint, and more ink to draw the bracket. Whoops. So we get a bracket at 3. What do we get for our right endpoint? With what? Infinity, because it goes forever. And infinity always goes with a parenthesis. Give me thumbs. How we doing? Okay, good. All right. Then we graduate. Actually, we got another inequality to solve. So what about this one? What are we going to do here? We got to distribute first. We got to simplify first. Good. So we'll distribute the 3 and get 3x minus 3 is greater than or equal to 3x minus 15. What's next? Okay, yeah, so what would you do with the x's? Subtract 3x, right? No matter which side you try to push the x's, they're going to disappear from both sides, right? So we subtract 3x from both sides, and that's when something weird happens, right? We end up with -3 is greater than or equal to -15. So the x's, when the x's go away, how are we going to interpret that? It's true, yeah. There you go. Okay, good. Because that's a true statement, the answer is going to be all real numbers. So now how would we answer this here? We've got 3 choices. Yeah, we're just choosing option what? B. That's it, right? We just choose option B, and we're done. It's all real numbers. What if the statement had been false? Would have been no solution. There you go. Okay, good. All right, so then we graduate up to compound inequalities. Is this an and or an or? It's and. Yeah, right. How many letters in and? 3. How many parts of an and inequality? 3. There you go. 3 columns or 3 parts. So how do we solve this thing? Subtract. Say it again. Well, now hold on. When we're solving, it's been a weekend, so I get it. Okay, good. And what's our goal here? Don't give me specifics yet, but what do I want to try to do when I'm solving an and inequality? Isolate x where? In the middle. Exactly. I'm just going to do the same thing to all 3 parts in order to isolate x in the middle. So we're just going to use inverse operations. First step would be what again? Subtract 6, good. So we got to get rid of that guy. So we're going to subtract 6 from all three parts, which cancels that 6. That's good. That gives us, what, negative 12 over here. I get a negative 2x in the middle, and 8 minus 6 is 2 on the right. What's next? Divide by negative 2, which means what? Yeah, good. Because we divided by a negative, right? Because we divided by a negative, we've got to flip those inequalities, right? And so we end up then with, let's see, negative 12 divided by negative 2 is positive 6. We get an x in the middle. 2 divided by negative 2 is negative 1, and we had to flip those guys around. Okay, so do we leave it like that? No. Mm-mm. And they want us to write it in 3 ways. They want us to write it as an inequality first. Well, there's our inequality, but it's backwards. We've got to flip that thing around. Right, so for part A, for the inequality part, here we'll do that. That one will be in blue. For the inequality, when we flip that around, the x is in the middle. How would I write it?
Negative 1 is less than or equal to.
Okay, so x is greater than or equal to negative 1 on the left, and
X is less than or equal to 6.
just less than 6, right? When we flip that. So it looks like that. Everybody good with that? Give me thumbs on that part, on twisting it around. Is that good? All right. Okay, then they want interval notation, but of course we're going to graph it first. So what's that graph look like then? If we've got, where am I going to have endpoints on this one? Negative 1 and positive 6. Oh, and what kind of endpoint at negative 1? Can be closed because of the equal. How about at 6? Open. Good. Now, how am I going to graph this? If I want the values of x that are greater than or equal to negative 1 and less than 6, what part am I going to graph? Just the in-between part, right? Because I want the places where both things are true at the same time. Technically, if I were graphing these separately, it would have looked like that and like that, right? But we just want the overlapping region, which is in the middle, and we know that. And inequalities look like 2 endpoints with an overlapping region that we graph in between the endpoints, right? So our graph looks like that. Give me thumbs. How we doing? Okay? And then last, they want interval notation. Okay, so if we write that with interval notation, what's that going to look like? There's our comma, always goes in the middle. What goes on the left? Good, because we're graphing this interval, right? This single interval. Left of the comma goes the left endpoint, so that's going to be negative 1 with what kind of bracket? Okay, what's on the right? 6, that's our right endpoint with what kind of enclosure? Parenthesis. All right, thumbs. Man, I'm feeling good about this. This is going to be a good test. Okay, what about, and obviously that's an OR inequality. How do we graph, or how do we solve OR inequalities? Solve each one separately, right? So what's the only thing we have to do here to the first one? Good, and then we get x is greater than 5, or, what's our symbol for OR? V. Yeah, when we're using inequalities, it's a V. And then how about the other part? What do we have to do? Good, we subtract 4 first, good. And what's that give us? I'm going to push it over here. That gives us negative 3x is greater than or equal to 3. Next step. Divide by negative 3. And what do we have to remember about that? Got to flip it. Good. We divided by a negative. So we've got to flip that guy, right? And then we end up getting, for our final answer, x is, I flip the inequality, less than or equal to 3 divided by negative 3 is what? negative 1. So there's our two parts of there's our solution, right? Written as an inequality. Now they want the solution in interval and graph form. Okay, so let's graph it first. There's our solution. What am I going to do? X is greater than 5 or x is less than or equal to negative 1. How am I going to graph that? How about the blue part? What's that look like? Okay, endpoint. What kind of endpoint? Open endpoint at 5. Good. Okay, so we get open endpoint at 5. And if we want the values of x greater than 5, everybody point. Which way are we graphing? Yeah, to the right. We want bigger values, so we graph to the right. Okay, how about the red inequality? Where's the endpoint? What kind? Closed. Okay. And everybody point. Which way are we shading if we are graphing if we want x, values of x less than or equal to negative 1? Everybody point. Yeah, to the left. There we go. Okay, so then what's that going to look like if I graph this with interval notation? So obviously the solution set is not, what does that mean? That no solution or empty set. So it's not, there is a solution, so it's obviously not that. It's part A, isn't it? We're going to choose A, but then we have to write the solution set, and they want it in what kind of notation? Interval notation. So we'll do the red, we have to do, with interval notation, we have to do this exactly like the graph. So on the left, we want to have the red interval. Okay, good. So we know the left endpoint of the left interval is negative infinity. What's the right endpoint of the red one? Negative 1 with what? With a bracket. Good, because it's closed. Then that's our symbol, right? U is the symbol for OR with interval notation. Remember how we remember that one? If we tip that guy over, it looks like a parenthesis. We use a V for inequality notation because if we tip it on its side, it looks like an inequality, so it's easy to remember those. And then how about the blue part?
Parenthesis 5.
There we go. So we have left endpoint of the blue part is at 5 with parenthesis because it's open, and then there we go. And it goes forever to the right. Okay, give me thumbs. Oh, this is good. All right. Okay. All right, now this is kind of a tricky one, right? This is one, it looks really simple, and it's not difficult, but you got to think on this one. You got to be careful. So they want us to give the solution set, they want to graph it and give the solution set in interval notation. Okay, so let's graph it first. Let's graph both of these two parts. So how about the red part? X is less than or equal to 2. What's that look like? Closed endpoint at 2. Everybody point which way we're graphing. Good, to the left. So we get something like that. Okay, let's make this one blue. X is less than or equal to 7. What's that look like? Closed endpoint at 7, graphing to the left. Now, yeah, so which part are we going to keep? If this is an OR statement, is this a union or an intersection? OR statements. It's a union, right? Not an intersection. So we're not just keeping the part where they overlap. We're keeping all the parts where either one of them is graphed. So if I graph the solution in purple then to this, where would I start, at 2 or at 7? I start at 7, yeah. I start at 7 because any place where an ant could be walking on either red or blue is part of our solution. So we start at 7 and go to the left. Okay, so there it is. I guess there's our solution. So we do have a solution. So it's A. And in interval notation, what would that purple interval look like? What's the left end point of our purple interval? Negative infinity with parenthesis. Good. And what's on the right? 7 with a bracket. Okay. Good. Makes sense? Okay. Now, what if, did I do another one? No, I didn't. Okay, what if this had been an AND statement? What would my solution have been? Yeah, okay, if it was an AND statement, I only would have graphed everything from 2 to the right because AND means intersection, and I would have only kept the part where both are true, where they overlap or intersect. Okay? So make sure you remember the difference between and or. Okay, then we move on to just regular old absolute value equations. Now notice probably on the assignment and on the review and on the test, it's going to give you these instructions to use a graphing calculator. Obviously ignore those. We're not using graphing calculators. We're just going to do this algebraically and then we'll graph our solution. Okay? All right, so what do we do? What's our strategy for solving an absolute value equation? Isolate the absolute value first. So the first step is what then? Add 6. Good. Add 6 to both sides. Those guys cancel. And so then I get absolute value of 2x minus 5 equals 3, right? And that what we just did there, that whole step, this was just isolate absolute value, right? Okay, once we've got the absolute value isolated, what's next? Oh, you know what? I wanted that to be wrong color. Got to stick with my color scheme, so that was a 3. Now what do we do? After we isolate the absolute value, next part is? Okay, but what do we have to do? Good, we're going to split it. Good, now we split it. Okay, we split it. So we get whatever's inside is either going to equal either 2x minus 5 equals what? What's one possibility? Could equal positive 3. Or what's inside could equal what? Negative 3. It's either going to equal the positive outside number or the negative outside number. So what do we call that step? Well, that is split the absolute value equation into two regular equations. And what's the last part? Solve. Just solve those, which is really easy. What are the two steps to isolate x? Add 5. So if we add 5, we get 2x equals 8. So what's one solution? X equals 4 is one solution. And then over here, we would do the same thing. We add 5, and that gives us 2x equals 2. So if I divide by 2, what do I get? X equals 1. So those are my two solutions. And I'm going to choose A, right? We didn't get the empty set. We got a solution. Empty set means no solution. So it's A, and our solutions were 4 and 1. What do you know? Okay, good? Give me thumbs. How we doing? All right. I like it. And then the other type you're going to see on the test is one like this, and that's it for absolute value equations. So what do I do when I've got something like this where I have an isolated absolute value equal to another isolated absolute value? Okay, good. I'm splitting the same way, right? Splitting the same way. So what's inside the first one? So all this stuff is either equal to what? Okay, positive or negative, right? So either it's going to equal what's in the other absolute value, the positive, or what's inside the first absolute value is equal to the opposite, or the negative of what's inside the second absolute value. So we didn't really have to isolate anything because that part was already done, but this is the split step, right? We split it into two equations and then we just solved those. So how would I solve the first one? Probably push the y's in which direction? To the left, yeah. So we'll add 3y. And if we're pushing the y's to the left, where are we pushing the numbers? To the right. Add 2 to both sides, and we get 5y equals 13 plus 2 is 15, so what's one solution? Y equals 3. Or the other one, what would I do first on this one? Good, distribute. So we get the equation 2y minus 2 equals negative 13 what? Plus 3y. So this time where are we probably pushing the y's? Doesn't matter, but probably a little easier to push them to the right so we get a positive number. Okay, so we'll subtract 2y from both sides to cancel the numbers on the, or the variables on the left. If the numbers are going right, the numbers are going left. So we'll add 13 to both sides. 3y minus 2y is y. Negative 2 plus 13 is what? Positive 11. So there we go. We got two solutions. Okay, so again, we're choosing A. We do get answers. And our answers are 3 and 11. Okay? Thumbs. Oh, man, you guys getting tired of putting your thumbs up? That's good. That's good. Okay, now absolute value inequalities. Okay, so very similar. What's first step when I'm solving an absolute value inequality? Isolate the absolute value, just like an equation. So step 1, we're going to subtract 3 from both sides, and we get the isolated absolute value of x plus 3 is greater than or equal to, that's important, 11 minus 3 is 8. So there's our isolate the absolute value step. Now what? Split it. Okay, this is the part where you got to be careful. Now, is this, when we split an absolute value inequality, depending on the direction of the inequality sign, we're either going to break it into a compound or inequality or a compound and inequality. Which one is this? Or. It's or. Okay, I thought of another way to think about this. If you, just in case you need, I'm always trying to give you ways to remember stuff. Discard this if you don't need it. If this is confusing to you or you don't need it, just forget about it. But one thing you could do is again, take it or leave it. What if I were to rotate this thing clockwise 90 degrees? If I rotate this clockwise 90 degrees, does that look like an and or an or? Looks like an or. There you go. What do you know? Okay, so it's an or statement. Okay, and we'll just ignore the equal part too. We don't really need the equal part. We just need the inequality part, right? So that turns into an or statement. Now, how do we split this into an or statement then? What's our pattern here? Okay, so what's inside, right, is either what? How do we make this into an or? We got to have two parts to this, right? Greater than or equal to the positive, right? Okay, so greater than, oops, what am I doing? Made an or statement. Greater than or equal to positive 8, or what's inside is what? There you go, less than or equal to the negative. Those are pretty easy to solve. What do I get in the first one if I solve it? Just subtract 3 from both sides. X is greater than or equal to what? 5. Or, how about the second one? If I subtract 3, what's negative 8 minus 3? Yeah, or x is less than or equal to negative 11. Okay, so now we got 5 choices. You guys tell me which one of those is going to match our answer. C. Yeah, the only one that matches ours, which is an or statement, And they use the word or instead of the symbol. That's fine. The only one that matches is C. Okay, everybody see that? Give me thumbs on that part. Everybody get that? That's the only one that would make sense. And then what do we say? X is less than or equal to negative 11, or X is greater than or equal to 5. Okay? And then they wanted us to graph the solutions. Okay, well, what's the X is less than or equal to negative 11 part look like? That's kind of hard to graph on this one, but where would I start? Negative 11, so like right there. Which way am I graphing? To the left. And how about the X is greater than or equal to 5? Closed end point at 5, graphing to the right. We got it. Okay, good. All right. Okay, same kind of deal. What's our first step? Isolate the absolute value. Excellent. So we are going to add 6 to both sides. I got a question for you here. So before we jump into this, I've had a couple people say, okay, this one's no solution or all real numbers because I have a negative on the other side. Is that right? We don't really look, first thing we always have to do is isolate the absolute value, and then we'll check to see if there's a negative on the other side. But first we always isolate the absolute value. Okay, so we get isolated absolute value of x minus 2 is less than or equal to positive 2, right? Okay, again, we could do something tricky here, right? We could take this less than symbol, and if I rotate that 90 degrees clockwise, does that turn into and or? Turns into and. There you go. Okay, so and inequalities have how many parts? 3. Good, so we're going to set up 3 columns. What goes in the middle? Yeah, whatever's inside the absolute values goes in the middle. What goes on the left? Negative 2. The negative outside number on the right? Positive 2. What's the only one step I have to do to isolate the x? Add 2. Good. Okay, so if we add 2 to all parts, we end up getting x in the middle is greater than or equal to what? Negative 2 plus 2 is? What's negative 2 plus 2? 0. Okay, good. And then on the right, we get positive 4. So there's our solution. You guys tell me, vote with your fingers. 1 for A, 2 for B, 3 for C, etc. Which is the one that's going to match for us? 2. There's our 3-part and inequality. Good. And we already have the solution. X is greater than or equal to 0 and less than or equal to 4. We got it. If I graph that guy, what's it look like? Closed end point at 0, closed end point at 4, and I graph in between. Give me thumbs. Good stuff. Okay, this is a weird one. We got an isolated absolute value of x is less than negative 8. What's going on, Leighton? So is that going to be a no solution or infinite solutions? No solution, right? And just ask yourself, whenever you see the negative over here, what I would say is just always ask yourself a how often question. How often is the output of an absolute value less than a negative number? How often? Never, right? The answer is never. So what's our answer? No solution. There you go. Okay. What if you have one like that? What if you have the output of an absolute value is greater than or equal to a negative number? How often?
Always.
Always. That's always true, right? Okay, so then how am I going to answer this one? The answer is obviously A. It's not no solution. It's obviously A. They want the interval notation. Oh, I guess I already gave you the answer. They want the interval notation for all reals. Well, isn't it just that? Everything from negative infinity to positive infinity? How do we feel about this? Good? All right. Test tomorrow.